Gauss-Newton method is a good iterative method to be able to solve unusual functions, let's say. But a potential problem of Gauss-Newton method is that as developed to this point is that the partial derivatives of the function may be difficult to evaluate. The function can be complicated to be able to get derivatives, basically. Consequently, many computer programs use difference equations to approximate the partial derivatives. So we learned that the partial derivatives can be calculated using finite difference, for instance, and the computer programs can use them. One such equation is this. The partial derivative gives the difference of f xi's and f xi. Actually here, this is the regular function, but here there is a delta, a small fractional perturbation. We have if you remember in the finite difference, we have the difference of functions for the current and previous, or for the current and the forward. So this is basically the same idea, and divided by that perturbation or the difference. And the Gauss-Newton method has a number of other possible shortcomings. It can converge slowly, oscillate widely, and continually change directions, and it may not converge at all. So these are regular actually issues of each iterative method. And a more general approach is to use nonlinear optimization routines. So in these, a guess for the parameter is made initially. The sum of squares of the residuals are computed using this sum of squares function. Then the parameters are adjusted to minimize SR using optimization techniques. In the end, you find the parameters by using this nonlinear optimization routine. We can use nonlinear regression in MATLAB using some optimization algorithms in MATLAB actually. Fmin search is the most commonly used function for optimization for nonlinear regression. Basically, with nonlinear regression, we mean that we have a polynomial which is not suitable for the general regression form of the regression that we learned so far. And in the fmin search, we will have the function, and this function will have the sum of squares function. We will show that in an example in the following slide. X0s are the coefficient values, initial coefficient values. Because the coefficients are unknowns for a function, we need to define them here. Options are the a structure containing values of the optimization parameters as created with optimset function. This may not be necessary. We usually use the default values. But to use default values, you can put a bracket for this, just a bracket here. P1s and P2s are the addition arguments, but these are the data actually. So we will have some X inputs and Y outputs. Those X's are not the same as this X. This X is the coefficients actually, but these can be defined as the input values, and these are the output vector. Then we can, find the coefficient values for the function that we want to fit to the data, to this data. Let's solve this. Use this in an example to solve in the following slide. In this slide, we have an example for nonlinear regression in MATLAB, and we will use nonlinear regression for this data. You can see here, inputs are these, outputs are these, and we want to fit a function of, I can write the function here as well, y equals a1 x a2, or you can say a0 x a1. a2 is to the power, x to the power a2. So we want to fit this function. So this is a different function that we fit before, and this is actually a nonlinear function. So we need to use actually the optimization procedure. For that, we need to write first an M file to be able to create the sum of squares function, because we want to minimize it. Let's write an M file, fssrm, and this function will use this function here to get the values with the unknown coefficients. So these will be initial coefficients first. For example, if we'll start with ones for the initial guesses, a1 is 1, a2 is 1. Use the data, x m values are these data. Calculate y values. These yp's are the predicted y values from the function with estimated coefficients, let's say. Also, we will have yms. Yms are the actual data. We have actual data values here. And the difference of these and square of it, and summation will give us the sum of squares, and we want to minimize this anyway. So this function is used to calculate this objective function, which has to be minimized. Then in MATLAB, in command mode, we can define x's and y's here. Then we use fmin search function. The function is the minimized objective function is this. We want to minimize this. 1 is the initial guesses. The bracket eliminates the options and uses the default for options parameter. X's and y's are these data. X's are v's, y's are f's. When you press enter after this, it will solve it in an iterative procedure and give you the results of this and this. And basically it means that we have a y function of a1 2.5384 times x a2 1.4359. Basically this, we obtain this nonlinear function which is fitted to the data here. So you can show this in with f's and v's because y is f actually and x is v. You can see here the function is like this. We can plot this and this, you can see the data here, and the black line is this function. We can also use and it's called untransformed actually. This one is the black one. You can see it goes well around the data, but we can have other options as well. So if you remember, for such functions we said that we can linearize these using, for example, log10 base, then use the linear regression, then transform it back to this power equation. If you do that, you will obtain this dashed line, and this is also, as you can see, going well with the data, and both of them can be good. You can check the correlation coefficients for both and see how it works, and you can also, as an exercise, fit a linear regression by linearizing this data by using log10 base, and to have the results and compare them like this. We have completed chapter 14 here, and this is actually in your book, chapter 17, and polynomial, generalized, and nonlinear regression sections. So we basically showed you the polynomial regression, generalized regression formulation, and also the nonlinear regression in the book. So you can read these sections in these pages to be able to have further understanding of them. Thank you very much for listening, and see you in other classes.